From a distance, Europa looks silent. A small, pale moon orbiting the giant mass of Jupiter. Its surface is cracked, frozen, scarred by long brown fractures that look like veins beneath ice. For decades, scientists assumed it was just another frozen rock. Lifeless, inactive, irrelevant. But the surface tells a different story. Those cracks are not random. They are signs of movement, of pressure, of something pushing from below. Europa is covered by an ice shell that may be 10 to 30 kilometers thick. And beneath that shell, scientists believe there is something extraordinary, a global ocean. Not a lake, not pockets of water. An ocean larger than all of Earth's oceans combined. This changes everything. Because on Earth, wherever there is liquid water, there is life. From volcanic vents in the darkest parts of our oceans to acidic lakes and frozen deserts, life finds a way. Europa is not warmed by the sun. It is warmed by Jupiter's gravity. The immense tidal forces stretch and squeeze the moon, generating internal heat. Enough to keep an entire ocean from freezing. A moon that should be dead might be one of the most promising places for life in the entire solar system. The idea of an ocean was not science fiction. It came from data. When the Galileo spacecraft flew past Europa in the 1990s, it detected something strange, a magnetic signature that shouldn't exist. The only explanation was a salty, conductive liquid beneath the surface, an ocean interacting with Jupiter's magnetic field. Then came the images. Long, chaotic terrains where the ice looks like it melted, shifted, and refroze. Regions that resemble broken sea ice on Earth. Even more intriguing, possible water plumes. Observations from space telescopes suggest that Europa may occasionally spray water into space through cracks in its crust. If true, that means we don't have to drill through kilometers of ice to sample the ocean. The ocean might be spraying itself into space. A frozen world, leaking signs of a hidden sea. Life on Earth does not need sunlight. At the bottom of our oceans, around hydrothermal vents, entire ecosystems survive in total darkness. They feed not on light, but on chemistry. Minerals. Energy from the planet itself. Europa's ocean floor could be similar. If Europa has hydrothermal activity, then it has all three ingredients: liquid water, chemical energy, and time. Billions of years of stability. That is more than enough for life to start. Not intelligent life. Not cities. But microbes. Organisms. Something alive. And if life started twice in one solar system, on Earth and on Europa, then life may not be rare in the universe at all. For decades, Mars was the priority. But Europa quietly climbed the list. Because Mars shows signs of past water. Europa may have water right now. That single difference changed NASA's priorities. Scientists realized, if we want to find living life, not fossilized traces, Europa is the place to look. And so, humanity decided something bold. We're going there. Reaching Europa is not the hard part. Surviving Jupiter is. Jupiter is wrapped in radiation belts so intense they can fry spacecraft electronics in hours. Any mission that wants to study Europa must pass through this invisible storm again and again. This is the true engineering problem. Europa Clipper is built like a vault. Its most sensitive electronics are sealed inside thick radiation shielding. Instead of orbiting Europa, it will orbit Jupiter and perform dozens of fast flybys. And measure out. Over and over. This is not a landing mission. Not yet. This is reconnaissance at extreme risk. Because before we drill ice, before we send submarines, we must answer a simpler question. Where is the ocean closest to the surface? Where are the freshest cracks? Where do plumes erupt? Europa Clipper's job is to map the invisible. Europa Clipper carries something extraordinary, ice-penetrating radar. Radar waves will pass through the crust and reflect back, revealing the thickness of ice and the possible lakes trapped within it. Like an ultrasound for a moon. Thermal cameras will search for warm regions where the ocean pushes closer to the surface. Spectrometers will analyze the chemistry of the ice, searching for salts and organic molecules that may have risen from below. And if a plume erupts at the right time, Clipper will fly straight through it, tasting the ocean without ever landing. We are not guessing anymore. We are scanning, measuring, sampling. Clipper is also a scout for the future. A future lander will need a safe place, a thin crust, active geology, access to recent material from the ocean. Clipper's maps will decide where humanity touches Europa for the first time. It will identify chaos terrains, regions where the ice looks shattered and refrozen. These may be the places where the ocean recently broke through. We are choosing carefully where the first drill will go. Europa Clipper is not the mission that finds life. It is the mission that makes that mission possible. Years of travel, dozens of flybys, petabytes of data, all to prepare for a single future moment when humanity dares to drill into alien ice. This is patience on a cosmic scale. We are laying the groundwork for the greatest biological discovery in history without even knowing if it will happen. And that is the beauty of it. It will not be dramatic. No creatures, no movement, no sound, just data. A chemical signature that should not exist unless something is alive. A microbe. And that tiny confirmation would change biology forever. Because life would no longer be a miracle that happened once. It would be a process that happens when conditions are right. Twice in one solar system. That means the universe may be full of life. The shock would not be scientific. It would be philosophical. Are we unique? Were we ever? Every belief system, every story about our place in the universe would be forced to expand. We would not be alone. Not in intelligence, but in existence. If we find life, the next step is inevitable. A lander, a drill, a cryobot that melts through ice, a submarine released into an alien ocean. We will not stop at detection. We will go down there. Europa is not just a moon. It is a question. A question we are finally brave enough to ask with machines, mathematics, and patience. Are we alone? And for the first time in history, the answer may come not from philosophy, but from ice, water, and data.